Right, I've had a little look at the condition where the first cut is made and then you specify the second cut has to be to the left. So if the first cut is positioned here somewhere, then the second break's got to be between there and there. Now I first thought that because that graphical chart had two triangles and the area of those was 1/4 of the total space, that this would just eliminate one of them and you would go down from 1/4 to 1/8. But the simulation on the spreadsheet showed it wouldn't work at all. So I've had a look at it and I think I now understand what's going on. If we make the first cut at this position at a distance x from the left hand edge and we move it around like this, clearly what's left here is 1 minus x. So we move it around and just have a look what's going on. The second cut has got to then be between A and this point. So there are banned regions you cannot go. If we made the second cut past point C, you'd be more than halfway. So A to wherever you go, that distance would be greater than 0.5 and the condition doesn't work. So wherever your first cut is, to the halfway point is a banned zone, can't go in there. Similarly, if you make the cut too close to A, then you would leave the center section greater than half, and then that also wouldn't work. So this blue bit is the only range that could possibly work. Now a little bit of thinking will show that that is also 1 minus x, because if we were to add up all the bits and pieces, you can see that that works out. I can show you graphically there, they stay exactly the same. So if they were 0, or if they were halfway, or if we go right over to the end, obviously those two distances are exactly the same. So first cut made there, second cut has to be in the blue range. So for that position, the probability of it working is the ratio of 1 minus x over x, because x is the possible range of cuts, 1 minus x is the only allowed range. So the ratio is going to be 1 minus x over x. So if you go closer to here, 1 minus x gets smaller and smaller and smaller and smaller. So the probability goes to 0. Whereas if you move in this direction, you rather increase the probability. The blue region gets bigger and bigger and bigger. Now, integrate then. I thought originally we might need some calculus. I can't figure out how to do an integral sign with the limits in this, but if you then integrate 1 minus x between 0.5 and 1, so it's between 0.5 in the middle and going to 1 at the end, play around with that, it's log n of 2 minus a half, which comes out at 0.193 something, and hey presto, that is what I got with the simulation. So that's worked out quite neatly, but it's quite satisfying when you finally get some kind of a graphical simulation of what's happening that ties in with the mathematics. So there we are. It'll be 19.3%.